What if I told you that everything we can see, every star, planet, galaxy, and nebula, only makes up less than 5% of the universe? The rest, it's invisible. We can't touch it. We can't see it. Yet it silently holds the cosmos together. We're talking about dark matter, the invisible framework of the universe. In this video, we're diving into what we know, what remains a mystery, and why it all matters. We'll explore the evidence that proves dark matter exists, dive into the leading theories on what it could actually be, and take a look at the cutting-edge experiments trying to detect it right now. Let's begin with a puzzle. Back in the 1930s, a Swiss astronomer named Fritz Zwicky was observing the Coma Cluster, a gigantic gathering of over 1,000 galaxies. But something strange came up. These galaxies were moving way too fast. By all logic, the cluster should have torn itself apart, but it didn't. It was as if something unseen was providing extra gravity, holding the structure together. Zwicky called it missing mass. Today, we call it dark matter. Fast forward to the 1970s. American astronomer Vera Rubin noticed something just as bizarre. She observed that stars at the outer edges of galaxies were moving just as fast as stars near the center. According to Newtonian physics, that shouldn't happen. Stars farther from the center should orbit more slowly, but they weren't. It was like galaxies were swimming in huge halos of invisible matter, stretching far beyond what our telescopes could see. Before we dive into what dark matter could be, let's clear up a few things it's not. First, dark matter isn't just regular stuff that's hard to see, like black holes, wandering planets, or clouds of cold gas. Scientists have carefully accounted for all those, and they don't explain the gravity we're seeing. Second, it's not antimatter. When antimatter meets normal matter, it releases a burst of gamma rays, and we're not seeing nearly enough of those to explain the mystery. Third, some have suggested maybe we just don't understand gravity well enough. There are alternative theories like modified Newtonian dynamics, or MOND, that try to tweak gravity itself, but they still fall short of explaining the full picture. So see, what is dark matter? To be honest, we don't know yet, and that's what makes this so exciting. Here's a quick challenge for you. If you could rename dark matter, what would you call it? Drop your ideas in the comments. Now, the case for dark matter doesn't rest solely on galaxy rotation. Here are 3 more powerful clues. First, gravitational lensing. Einstein's theory of general relativity tells us that mass bends light. And when we look at distant galaxies, we see their light warped and distorted by something massive and invisible. In fact, we can even map where dark matter is by measuring these distortions. Take the Bullet Cluster, for example. It's the collision of 2 galaxy clusters. The visible matter slowed down from the impact, but the gravitational effects didn't. The result? A separation between what we see and where the gravity is, almost impossible to explain without dark matter. Second, the cosmic microwave background, or CMB. This is the oldest light in the universe, left over from just 380,000 years after the Big Bang. Its tiny temperature variations match perfectly with models that include dark matter. Remove dark matter from those models and everything falls apart. Third, computer simulations. Scientists have tried simulating the formation of galaxies without dark matter, and the results don't even come close to reality. But when dark matter is included, the simulations produce galaxies that look just like the ones we observe in the night sky. So what could dark matter actually be made of? 2 of the leading candidates are WIMPs and axions. WIMPs, or weakly interacting massive particles, are hypothetical particles that have mass, but interact very little with regular matter. They might have been created in the early universe and could be floating through space even now. Axions are much lighter particles. Originally proposed to solve a problem in quantum chromodynamics, axions could have been produced in enormous quantities early on, and might even turn into photons when exposed to strong magnetic fields. Here's something wild. If dark matter is made of axions, trillions of them could be passing through your body right now, and you wouldn't feel a thing. There are other possibilities too. Sterile neutrinos, primordial black holes, or even some unknown form of matter we haven't discovered yet. So how do scientists search for something they can't even see? The answer, with incredibly sensitive experiments. Deep underground labs like Xenon and Lux use giant tanks of liquid xenon to catch dark matter particles. The idea is simple. Maybe, just maybe, one of these particles will hit a xenon atom and release a tiny flash of light. These detectors are placed deep underground, often in abandoned mines, to block out cosmic rays and other interference. They're also surrounded by water and shielding to minimize natural radiation. Think about this. Scientists are trying to detect particles that can pass through the entire Earth without leaving a trace, using some of the most precise machines ever built. Other experiments aim for different strategies. The Large Hadron Collider tries to create dark matter particles by smashing protons at nearly the speed of light. Space telescopes like Fermi look for gamma rays that might be given off when dark matter particles annihilate one another. So far, no detection has been definitive, but every experiment helps narrow the search. Dark matter isn't just some abstract mystery. It's essential to how the universe was built and how it's evolving. Without dark matter, galaxies may never have formed. No galaxies, no stars, no stars, no planets, no planets, no us. Its gravity pushes back against dark energy, the strange force that's making the universe expand faster and faster. You can think of the universe as a cosmic symphony. Ordinary matter, stars and galaxies are the soloists, dazzling and bright. Dark energy is the steady rhythm pulling everything apart. And dark matter, it's the unseen conductor guiding everything silently from the shadows. We know it's out there. We can see the effects of its gravity. We've got strong theories about what it might be. And scientists across the globe are racing to detect it. The search for dark matter isn't just about solving one big mystery. It's about uncovering the true nature of reality. Maybe soon we'll catch a glimpse of these elusive particles and unlock a new chapter in physics. What do you think dark matter is? Got questions about anything we covered today? Drop them in the comments below. And if you enjoyed this journey into the unknown, hit that like button and subscribe for more trips through our mysterious universe.